We're sort of like really expanding far out now, but like, would you like to always have some sort of hands-on? Let's just way far out. Would you like to always have some sort of hands-on role here, or would you want to step back and be in a position where the people who are experts in this space are the ones that are really driving things forward?
I always wanted to be able to have like being able to give feedback. I always want to be able to like contribute in substantial way. Even if I don't understand all the problems, I can still glean what's kind of going on. Like I've got friends that do ASIC things with like RISC-V chips, and even though I didn't go to college to learn this, I've seen enough, I've played around enough that I can kind of glean enough to be able to see what ideas I could throw out there.
Mm-hmm. This is all stuff that's like well into the future.
Like 10 years from now, yeah.
Right, right. So, I guess, yeah, like, the, honestly, I think this is a really cool project. Like, this is a space that I've just never really, not even just like hardware development, even just hardware hacking is just a space I've never really delved too much into. I've always wanted to mess more with hardware stuff. It's just it's not something I've like. The main difference between doing software and hardware stuff is the barrier to entry with software is the computing device you probably already have, right? With hardware, you're at some point gonna have to move things into a space with hardware, purchase things, and all of this.
Yeah, like there are basic enough FPGAs that you can do like pretty cool things with. You're still having to spend some amount of money. Like you cannot avoid the money problem with hardware. It is FPGAs make that much more accessible because they're effectively reprogrammable logic cells inside, and so you can just define things that are hardware.
So I don't think we touched on this earlier, but like, where did your interest in hardware come from?
That's a good question. I don't know. I just have a lot of interests, and then I decide to mess with something, and then I kind of just go down a rabbit hole.
Hmm. This rabbit hole's led you quite a way, though.
Yes.
Yeah. I,
I mean, that's how I ended up writing an operating system when I was in middle school.
hmm. Okay. Right.
Yeah.
There is a lot of There is a lot of documentation on doing that though. Like, I don't know what was present. I don't know how much of that is more recent stuff. But at least now, if you want to learn how to write an operating system, the documentation is absolutely out there. It's very obviously it's complicated. You're still writing an operating system, but if you have the drive to do so, it is a relatively approachable subject. It's not an area where you're lacking in good resources on how to do it.
Yeah, especially with like languages like Rust today, like there are like docbook wikis that are just like or like read the doc websites that are just like for 5 pages of how you can write a basic operating system that prints hello world and has memory management, stuff like that. You can just do it in a weekend. But with like 10 years like I think more than 10 years ago, this was like 2013, somewhere around that time. I wanted to write an operating system for some reason, and then the one resource that kind of existed at the time that still is around is the OS Dev Wiki. It has a lot of information out there. At the time, a lot of the information was still things like focusing on chip on processors from the 80s and 90s because those chips were simpler. Like designing an operating system that runs on a 46 is not that hard
Mm-hmm.
in comparison to like writing a 64-bit operating system with like user mode and a network stack and all of that. Like getting to that point gets very complicated, and like doing that all in C is complicated, and not having things break
Mm-hmm.
with like modern things of like Rust and like I know people will not like this, but like AI, like say as much as you will about like how things are with like AI as a tool, and like this is coming from someone who's been writing code since like 2012. It's a very useful tool, and you should take it with a large grain of salt. But when you have tools like Claude Code, if you know how to approach it from the right way, it can make workflows be a little bit more manageable.
Mm-hmm. I do want to talk a bit about the AI usage because this is something it's really you can't avoid at this point, right? Like any I know there are the becoming graybeards, the soon to be graybeards of the FOSS world, the now late 20, early 30-year-olds who they've been involved in the FOSS space since they were 18. AI wasn't a thing yet. But now with this, like I've said this many times before, I have friends in education. Every single new developer is basically using AI, whether it like to different extents, but they're all using it. This is something which is happening. We can pretend like it's not happening, but it is. And I understand wanting to do like artisan programming. You just enjoy the craft of programming, right? You know, people garden without using certain tools. Like, sure, whatever, totally fine. Like, absolutely respect. If that's what you want to do, if you want to build a house using hand tools, hey, totally fine. You're there. It's there to do it. But it obviously you did use Claude to some extent through this. What was that like? What did it help you do? And I guess, what are some of the limitations you ran into as you were going through this?
So one of the like one of the nice things is Claude Code. It is there are huge amounts of security concerns, so I recommend if anyone's using this thing, please run it in a micro VM. Do not give it access to your full system in case something happens.
Yes, there have been cases of, I don't know if it was Claude Code, but one of these systems being like, hey, just that database? Nope. Bye-bye.
Yeah. And if you don't want to use Claude Code, please stay away from OpenClaw. There's a vulnerability like every 3 days. But aside from that, when you have a AI model tends to that has the ability to run commands and kind of introspect what's going on, it has a way of being able to kind of decipher and sort of not really learn, but it has the way of picking up on how to approach things in a way that's going to cause less problems. Like
Mm-hmm.
you were like, "Hey, I have this problem. Uh, please tell me through it,"
Mm-hmm.
and it will kind of be like, "Well, let's look at the log files. Let's see what the error is. Oh, it erred because you made a typo. You can just fix this by just renaming."
Mm-hmm.
And so, like, it does get a lot more complicated, especially with what I'm doing. Um, but with how much content there is on the internet, and with how much like these models have been fine-tuned and trained on like the like collective knowledge of the world,
Mm-hmm.
it has gone to the point where you can use AI to design hardware. Like
Mm-hmm.
2 years ago, it could barely write software. Nowadays, anyone can make a SaaS product. there are going to be security concerns, I recommend people please don't use AI for security things unless you know exactly what you're doing and you know how to approach security, because you do not want holes in your security. Um, but when you're designing something like hardware where it's like something that doesn't really have any security impacts, and if you can own up to it and you can stand by the output that it gives, and you are certain that it will not have a problem, then use it. Like, it, yeah.
Mhm, mhm. So, I guess what are some of the problems you've run into with it?
Um, it being sometimes inaccurate, where it's just like, oh, let's just change these things because it seems like that error is like impossible. And it's like, well, no, let's just actually fix the problem and not work around it. Like sometimes it will use these little hacks, but I'm like, when you have hardware, or if you're wanting something to actually be like good, you do not want hacks.
Mm.
You want a real solution that will work. And it's like fine for testing like this little thing, that is okay.
Mhm.
Like a little hack to be able to see like what's going wrong, why is this thing this way. A little hack there is fine, but fix it up before you actually like get this out the door.
Mhm, mhm.